Now let's discuss next type of flip-flop. Name of that flip-flop is T flip-flop. So in T flip-flop there is only one input and that input is labeled as T. So block diagram. This is block diagram of T flip-flop. So here you can see that there is only one input. It is labeled as T. There are two outputs, that is Q and Q prime. Now this symbol indicates that this particular T flip-flop is negative edge trigger. Then operation. How T flip-flop operates. What happens in T flip-flop if T is 0 and if T is 1. So if T is 0 then there is no change. Okay, in T flip-flop if this T is 0 then there will not be any change in the output. What it indicate? It indicate that if present state of T flip-flop is 0 it will remain 0 only. If present state is 1 it will remain 1 only. So state of flip-flop is not going to change whenever T is 0. Then if T is 1 then what change is going to happen in T flip-flop? Then output of T flip-flop is going to toggle. Okay, so simple. If T is 1 then what change will happen in output Q? So if previous output is 0 then next output will be 1. If previous output is 1 then next output will be 0. Okay, so let's try to understand operation of T flip-flop with the help of this table. Okay, so in this table you can see first of all clock. Okay, so let us start with this first row. So what this symbol indicates? So let's assume that negative edge has been detected on the clock pulse. So whenever negative edge is detected on the clock pulse, what is going to happen? Output of T flip-flop is going to change as per input T. So here what is T? T is 0. So I told you that in case of T flip-flop if T is 0 there is no change. There is no change means output of flip-flop will remain as it is. Now here you can see the two terms like Qn and Qn plus 1. Already I told you what is Qn. Qn means present state. Okay, and Qn plus 1 means next state. Okay, so which is present state? 0. So if T is 0 what will be the next state? So here present state is 0, so next state will be again 0, because we know that in T flip-flop if T is 0 there will not be any change in state of the flip-flop. So here present state is 0, so that 0 will remain as it is. Simple. Now consider next row. What is T? T is 0. What is Qn? Qn is 1. So T is 0, Qn is 1 and negative edge is detected on the clock pulse. So output is going to change as per input. So input is 0. So that's why what will happen? No change. So this one will remain as it is. See, simple. Then consider next row. Here what is T? T is 1. So in case of T flip-flop if T is 1 then output is going to toggle. Output is going to toggle means if it is 0 then it will become 1. Okay, so we'll see this particular row. Here what is present state? 0. What is input? 1. Okay, so negative edge is detected on the clock pulse. So what will happen? This output will toggle. So output will toggle means this 0 will be converted into 1. Similarly for this last row, what is happening here? T is 1. So T is 1 means output is going to toggle. So this 1 will be converted into 0. So this is operation of T flip-flop. Now how T flip-flop can be implemented? So T flip-flop is obtained from JK flip-flop by connecting J and K inputs together. We have seen that D flip-flop can also be obtained from JK flip-flop. So how we obtain D flip-flop from JK flip-flop? For that we use inverter between inputs. Okay, so can we obtain T flip-flop from JK? Yes, it is possible. For that what you have to do? Simply you should connect J and K inputs together. So see, in this way, if here we have JK flip-flop, so here what we have done, we have connected both inputs of JK flip-flop together and then we will consider it as single input, that is T. So this particular circuit now it is going to act as T flip-flop. Now let's verify operation of T flip-flop here. So here T is 0. So we have discussed what happens in T flip-flop if T is 0, there is no change. Okay, so see, if T is 0, what will be the value of J? J will be 0 and K will also be 0. Because this 0 we have applied to J input as well as 0 is applied to K input also. So J and K both will be 0 0. So in case of JK flip-flop we discuss 4 cases. J and K both are 0 0, then J is 0, K is 1, J is 1, K is 0 and J and K both are 1 1. So I hope you remember that JK flip-flop. Okay, so in case of JK flip-flop if both inputs are 0 0, what change is going to happen in the output? No change. Okay, so output will remain as it is. So this is expected in T flip-flop, right? Okay, so it is correct. Now if T is 1 then let's see what will happen in this circuit. So I told you that how T flip-flop operates. In case of T flip-flop if T is 1 what change will happen in the output? So output should toggle. So see, if T is 1 so J will be 1 and what about K? K will also be 1. because simply we have connected this J and K together. So whatever input that I apply to T will become input for J and K. So J and K both will become 1 1. And in case of JK flip-flop, what happens if J and K both are 1 1? Whether this is the invalid combination for a JK flip-flop? No, this is invalid combination for SR flip-flop. In JK flip-flop, this input, that is 1 1, is allowed. So in case of JK flip-flop, when both inputs are 1 1, what change happens in the output? Output toggle. So that is expected in T flip-flop, right? So in this way we can convert JK flip-flop into T flip-flop, right? Simply by connecting J and K inputs together.